Okay, let's learn something about robots with a sumo contest. You've probably seen Japanese sumo wrestlers. They're the big guys trying to push each other out of a ring in the dirt. This is the robot version of that. The rule is simple. Put two robots in the ring, and the first one to touch anywhere outside of the ring is the loser. There's another important rule. There's no remote control allowed. There are no human drivers in this competition. Instead, you'll write an autonomous program that will tell the robot how to behave. You'll figure out how to read the robot's sensors and decide how it should move. Here is a Simple Sumo Bot. This is built from a LEGO EV3 Mindstorms kit. This is the educational version, and build instructions can be found in the description. This robot has two wheels, there and there. Each one has its own motor. These are smart motors. They know how far they've moved. You might see an ultrasonic sensor in the front. Not all of our robots have those. And the battery is underneath. And this is a color sensor. It's actually a single pixel camera. Unlike your cell phone, which probably has millions of pixels, this one has only one, but it's a big one. It's about the size of a quarter, so it can detect whatever it's going over. It also has a screen. There's the screen. Underneath the screen here is the escape button, and then there is a little control panel right here. These are arrow keys, up, down, left, and right, and in the center is the enter button. You also use that to turn on the robot. This one has an ultrasonic sensor on it. Not all of the robots will have that, and we won't need it for this lesson. So this is LEGO Mindstorms. This is the programming environment where we will create our instructions for the robot. We're going to click the plus icon right here to add a new project. The layout's pretty simple. This is a block-oriented programming language. So there's a start button right here. Everything we plug into the start button will start actions on the robot. Down here are, in the green tab, are the most common actions. These are motor control actions right here. This controls the screen, this controls sound, this controls the lights, the status lights that are around the cursor pad. We'll also be using the orange tab, which is flow control, and that'll make more sense in a little bit. When your robot is plugged in, you will see it down here. It'll say EV3. It might have a custom name, but normally it'll say EV3, and if you click on the port view, you'll see what's plugged into the robot right now. So it says that we have a motor on port B, another on port C, we have the color sensor on port 3, and we have the ultrasonic sensor on port 4. To write a program, you're simply going to drag these blocks up onto the play bar and configure them. So the very first thing we need to do is just get this robot to move. Okay, I'm going to add a quick 1-second timer block to make it wait, just to give me the chance to switch over to video. And we're going to try adding a motor block. So this block controls a large motor. To be clear, this is a fully functioning program. It doesn't do a whole lot of interesting stuff, but it will do something. I'll read it to you. This is controlling a large motor. There are different modes available. You can put it off, you can put it on for seconds, degrees, or for rotations. Normally we'll use it either in on for rotations or off, or just plain on or off. This is your speed setting. Positive values are going to make it go forward, and negative values will make it go backwards. And this is the number of rotations. Since we're in on for rotations mode, this button is here for us to say we want it to go 2 rotations or just 1 rotation or 0.5 rotations. This is the wait for completion button. We don't need to worry about that right now. And this says that we're controlling the motor on port B. Remember, there was one on B and one on C. So we're going to try this out and see what happens. I'm going to hit play. And you can see that it moved. And it turned a little bit. So I'm going to move the robot back. We're going to try switching it to port C and see what happens. And you can see it moved in the other direction. So in each case, we were controlling just a single motor, and it made the robot turn instead of sort of driving forward. And so why is that? So if you look at your robot, again, this is called a differential steer robot. And what that means is it steers based on the difference between what one wheel is doing and what the other wheel is doing. So you can place your fingers on the top of the wheels and you can make the robot move that way. And you'll notice that if you make just one wheel turn, it's going to pivot on the other wheel. If you make the other wheel turn, it's going to pivot on this wheel. If you make them both go backwards at the same speed, they're going to go backwards. And if you make them go forward at the same speed, that's what will happen. So you got to tell the robot how to do these things if you want to have these different behaviors. So I'm going to back it up again a little bit here, and we're going to experiment a little bit more. So one of the things we'd like to do is control both motors at the same time instead of just one. So I'm going to get rid of this block. I'm going to just click on it and hit the delete button on my keyboard. And then I'm going to go down here to one that says move tank. And I'm going to drag this one off. Now if you accidentally drag it to here, you'll see that it's sort of grayed out. That means it's not active. You can leave it sitting there. It won't harm anything, but it won't take part in the program. So I'm going to move it back up here. And you see that gray bar? It's going to snap to that location. And it's ready to go. So this one says, this one controls both B and C ports, so both of those motors. Again, it has the different kinds of modes and your power settings and a rotation value. So I'm going to hit play on this one. And I made it go straight forward. So if I want it to turn, I can just put one of them all the way up, put the other one all the way down, and let's see what happens. And that was a turn in place, like it didn't travel while it was turning, it just sort of rotated around the center of the robot. And that's because one wheel was going forward at full speed and one was going backwards at full speed. We can make the robot go backwards by setting them both negative. And here, make sure that it's not going to run itself off of the table. And you should be experimenting with these. You should try all of these out. And in fact, why don't you make sure you can make your robot turn left, right, go forward, come backwards while you pause this video and then come on back. So if you take a look at your sumo ring, you'll see it's a big black circle with a white border around the edge. So think about what your robot's going to do. It's going to be traveling over this surface, trying to look for your opponent, and then pushing that opponent off. But the first thing you want to make sure of is you don't lose. The rule is simple again, remember? It's just if any part of your robot touches outside of the ring before the other robot, you lose. And you don't need an opponent for that. You can do it yourself. You can tell your robot to turn on for 10 rotations and it'll drive itself right across the ring. So instead of making a giant number right here, you might have found that it took 5.5 rotations or something like that to go across the ring. But what we're going to do instead is we're going to set these values to forward direction because we want it to charge across the ring, right? You've noticed that the ring has that white border around it, and we told you that there is a sensor under the robot that will detect how bright the surface is. So if I turn it back over, I'm going to look over here and I'm going to see that the current value on this wood grain table is 37. So I'm going to grab a sheet of paper, bit of envelope here, and I'm going to put the robot on that. And you can see that red dot here, sort of. See that red dot? That is the light that is illuminating the paper, and it's measuring how many photons are coming back. You can see the value jumped up to 72 down here, right? 70s, somewhere around there. Again, let's go back over this, and it'll drop down to 3940 or so. Now we're going to grab something dark. So now the robot's over a black sheet of paper, and you can see that the value on port 3 has dropped all the way down to 2. It sees that as really, really dark. So very, very little light. It's almost approaching 0. So if I move it over to the white sheet, again, it jumps back up to the 71, 72 range. So we know that a dark value is going to almost always be down below about 15. So we like to use that as a cutoff. So what we want to do is we want to learn how to detect when it's under 15 and tell the robot to stop. So we're going to back up here. So I'm going to tell the robot to go forward, and instead of going 5.5 rotations, I'm going to just take the mode off, and I'm just going to tell the robot to turn on. So if we hit play, the robot's going to go forward, or is it? The question here is, if you hit play, you'll see it doesn't go anywhere. It jerked just a little bit right there. That's because it's reached the end of the program. When you tell the robot to go on for seconds or on for rotations, it sits there inside this block measuring whether it has achieved that goal. If you only just turn it on, it's immediately going to just turn the motors on and switch over and go looking for that next block. But there isn't one, so it considers that the end of the program, and it shuts itself down for safety. So we actually need to keep this alive, and we'll do it with another one of these weight blocks. So I'm going to go back over here, and I'm going to go with a weight block, and we'll wait for 1 second and see what that does. So I'm going to hit play, and it drove off. And that is because in 1 second it can go a little bit further than it would for just one rotation of the wheels. But our interest isn't in going for 1 second, it's in going for, but you know, the motor was going the whole time. Now we're going to switch it. We want to go for the color sensor, and we're going to go to compare and reflected light intensity. That'll turn on that little red light that'll shine down, and it will measure how much light bounces back. But it also said compare, so this is the compare operation. So let me read this to you. This is the color sensor. And this is the operation. It's basically saying if the color sensor gives us a value that is less than, which is equal to a 4 down here in this table, less than a value of 50, then it will continue. Up until that point, it's just going to sit here and wait. So it's going to wait here until we see a value of less than 50. Well, we know that we're already less than 50, right? This is the part of the program where we're going to be charging across the field. We're going to be on the dark surface, and we're going to have this low value. So it's going to immediately stop. It's going to, and now instead of staying alive, it's going to stop. Right? It jerked a little bit, and then it did this test, and it saw, well, it's already less than 50. So it went for that next instruction, didn't find anything, and shut itself down. But we want to wait until we see a bright value. So we're going to go with greater than. And remember, we said it's always going to be below 15 when you're over something dark, or at least in the Sumo rings that we're using. So I'm going to put in 15 there. And now I'm going to hit play. And what it should do, if it's all right, is it should turn on the motors, and then it should wait until it sees something brighter than 15, which what that white piece of paper should show. And then it should reach the end of the program and turn itself off. Let's see if it does that. So it does. It turned itself off. It went a little bit less far, right? But it also sort of kept going. So let's try something else. Let's go back over here and let's do another motor command. Move tank, just like the last one. And this time we're going to tell it to go to 0 power. And let's see if we can make it stop a little bit more abruptly. So hit play. Yep, that didn't quite coast so far. But it still overshoots just a little bit. So that's the area where it's kind of dangerous. You might overshoot the edge of the ring. And again, if you touch out, you're gonna lose. Okay, maybe if we make it go backwards, it'll do an even better job. So I'm going to set our value backwards because we don't want to be that close to the ring. So I'll keep it going backwards for one rotation. And I'm going to hit play. I'm going to hit stop first. And then I'm going to hit play. Okay, so it comes back. And the next thing we got to think about is what do we want to do once we're there. We're now all the way across on the other side of the ring, and we found the border. We've backed away from it nice and safely, and we probably want to turn at this point so that we can face back into the ring. So we'll grab one more move block. And we want to do a turn, and as you remember, turns are when the wheels go in opposite directions. You can decide which wheel and which direction you want to turn. So we're going to try this one out. Hit play. And it turns. Okay. So at this point you have a fair amount of your program completed. This block is your charge across the ring. Hopefully you're going to find an opponent and push them out. These three right here comprise your escape behavior. This is when you detect the edge of the ring right here. You back away from it and you turn back around so that you're ready to charge again. Which means you kind of need to go back to here in order to start charging again. A common step now would be to copy all of these blocks. You can do something like edit, copy, and then edit, paste, and you can paste all of those blocks in and keep on going. You can scroll over here. But that's not really the best way to do it. I'm going to delete these and show you a better way, because at the end of this you'll have come back across the ring, found the next edge, escaped it, but then you'll be stalled again. So you kind of want to keep this behavior, this sequence, going forever, or at least for a little while. Let me fix that up. So I'm going to get rid of those. So we're back to the programs that we already had in, the full program. We're going to go to this flow control tab, and we're going to grab this really big one. This is called a loop, and I'm going to drag it up here in front right after this first wait timer. And I'm going to grab all of these by selecting them. And if you can't select them all together, you can select them individually. So I'm going to do that now. We're going to go ahead and pull it inside. Wait until this loop opens up. It automatically gets bigger, and you'll see the shaded portion there where it's going to drop in. And I'm going to make sure that all of these commands come in exactly the same order that we had them out here. Right there. And this is our turnaround. So this loop is simply a way to repeat all of the blocks that are inside of it. This one is set to loop forever. You can let it loop based on a count, like 10 times or something like that. But this one is just going to keep going until it runs out of battery or you pull it off the field and stop it. So at this point you have a testable Sumo program. Go ahead, test it on the field, and then ask your teacher to coordinate a tournament. Have fun.